Okay. Hello, everybody, and welcome to this meetup, this Hong Kong meetup, this virtual meetup. I'm very excited to be able to host this today here. I'm hosting this with David Liu, who is also the technical working group of China chair. And we have two people, Priyanka and Roy from Accenture, who are going to take us through BAF. A little bit of background on BAF, they will go through it, but it's a lab project of Hyperledger. They're Accenture, but this is not just for Accenture. It is a Hyperledger project, so it's open to everybody. So it basically contributed, I think, was it in October? So last year. So this is going to be a great meetup. I wish that we could all join for some food and beer, but this is virtual. So I'm now going to hand you over to Priyanka and Roy. Please take it from here. Thank you.
Thank you so much, Julian. Am I audible?
You are audible. Definitely.
Okay. Thanks. Thank you so much. So thank you everyone for this opportunity. I'm Priyanka. I've been with Accenture for almost 2.5 years now, and I've spent all this time in blockchain and blockchain implementations, projects, POCs, and architecture. Been involved with Hyperledger since we open sourced blockchain automation framework since last October, and it has been an amazing community feeling, and we are growing with it, and we hope to get more contributors and collaborators with this meetup. So with that, I'll just quickly give what today's agenda looks like. We'll first give you an introduction to Hyperledger Labs, because right now, blockchain automation framework is not a qualified Hyperledger project. It is under labs. So I'll just give a quick introduction. What does it mean really to be under labs? Then, I'll give an introduction on what this product is about and why did we really, spend time, or what was the need that we felt to build something like this. Post that, I'll hand it over to my colleague, Shaunak. So Shaunak will take you through the architecture, the sample fabric automation architecture that we have. Then we'll take you through the deployment demo, and we'll pause for Q&A. Though we have a separate section for Q&A, I'm sure if you have any questions, please post them on the chat, and we'll be happy to address that. Once we have done all the introduction, we'll also want to take you through how our current roadmap looks like, what are the key features we are working on, where we really want more people to come and contribute, or suggest additional features. So how to get more involved. So with that, if we can, I can start, I'll just go ahead. Okay, so there already is a blog on what is Hyperledger Labs, which I've pasted the QR code. So if anybody's really interested, you can just scan it and read about it. But a quick introduction is that it was launched in January 2018, and it's more like an incubation center. It's for those projects which are really very early stage, and as a lot of you might know, that to become a qualified project, there is a project proposal process, and there are a lot of other things, the legal framework that has to be complied with to become a qualified project. So the labs makes it a little easy for products for projects that are still in early stage to kind of get into labs first, and then to transition from labs to a qualified project within that legal Hyperledger framework. So, and it's also sometimes projects are at a too early stage for the TSC approval, the technical steering committee's approval, but they have a lot of promise. So even those projects come under labs, and then they are taken through. So I can also take you through what the current lab looks like. So let me know if you can still see my screen.
No. I mean, it's still showing the PPT.
Yeah.
Okay. I'll just show all windows. No, just give me a second.
And if people scan that QR code, what do they get?
They go to the link.
Okay, great.
So can you see it now?
Yeah.
Okay. Yeah. So this is where it will take you on, why do we even do a labs? What can be in the labs? How does it really work? And so it doesn't come under the TSC, but it comes under an initial list of lab stewards and who these lab stewards are. So yeah, you will get all these details here. What I want to take you through is, if you go to GitHub and you go to Hyperledger Labs, you will see a multiple number of projects that are under lab. The first one obviously is what we are going to present you today, which is blockchain automation framework. But if you can kind of scroll down, you will see a lot of other projects which are in here. And I can say that it's still in the early stage of incubation. Okay, so yeah, with that, I'll go back to sharing my slide. Okay, so and just to give you a bigger picture, if you see the Hyperledger ecosystem, you'll recognize all these names of the distributed ledgers. We have libraries, we have tools, and on the right corner, if you see, there is this Hyperledger Labs. So it's the small incubation center before the projects become the qualified projects. So now I would start on blockchain automation framework. You can again scan if you want, or you can just click on the link to see how the project is right now positioned on GitHub. Let me take you through the journey, right? So when we started working on blockchain, we started initially with POCs, because every client wanted a proof of concept. Every client wanted to know whether the technology will suit them, will work for them. The use case is a good use case for blockchain. So we would, and it would be budgeted in a, to kind of build something in a very quick way, if I can call it quick and dirty way, right? The problem that we started facing was a lot of POCs were created, but when we wanted to make them or scale them up to a pilot or a production grade solution, we would have to do the entire work once again. And the reason being, it's just not an application sitting on top of a server, right? It's an entire network that needs to be brought up. So there are a lot of nuances and technicalities that goes into when we are talking about blockchain implementation. For example, security is something that we need to consider. When we do a POC, we don't even worry about how the keys are getting generated, where are they stored, how the certificates are managed, etc. But when we really need to scale it up, when we really need to take it ahead, all those things are the actual crux of a blockchain network, and they make things architecturally different, how components interact with each other different, and we had to literally reconstruct the entire use case once again. So we understood that this is a gap where yes, we are doing things to demonstrate value quickly through a POC, but when we want to scale it, we are facing a lot of challenges. So what can we do differently to make it simpler for implementing teams, or even for developers who want to focus on writing the chain code or writing the use case or an application code, rather than literally worrying about setting up or bringing up or deploying a network? So with that, problem statement, what we are developing is what we call as blockchain automation framework. We kind of call it a bridge which is a trustable bridge from a POC to production in an automated way. So we the reason we are calling it production is because we have seen a lot of things available in the market on how to quickly deploy or quickly bring up a network. But do they really look into the details of security, scalability, etc.? Most of the times, the answer is no. So we wanted to do something which can be actually taken to production, that can be taken to the clients and is trustable. So with that in mind, we wanted to build something which supports multi-org, multi-company network, which is cloud agnostic, which is infrastructure independent. So uh, it could be very much that one organization is sitting on top of AWS cloud while the other one is sitting on Azure or anything else. So that is the entire concept and the problem statement on why we wanted to build this. Now, what we really did is to make things very simple. We depend upon a single file. So the framework consumes a single file, which we call as network.yaml file, where we kind of give the platform of our choice, consensus, the org details. In the world of Fabric, we give channel details, peers, anchor peers, etc. All those details in the single file, and the framework, which is an automation framework, consumes that and spins up a network. One important thing here is that we are spinning up the network, but we are not really spinning up the infrastructure. So infrastructure is something that is kind of I would say, a prerequisite, and Shaunak will be taking us through that when he actually shows the demo. But this is something that kind of becomes a point of query or confusion. So what we really need is existing Kubernetes cluster, so that on top of that, a network could be deployed. So that is the concept. With that, I hope I have not been seeing if there are any questions, but with that, I'll hand it over to my colleague, Shaunak.
Hello, hi. I am Shaunak Croy. I'm based out of Manchester in UK. And I work as mainly, as of now, my main contributions to Hyperledger is on blockchain automation framework as the main contributor and maintainer. As well, I'm also contributing to the Hyperledger Cactus project. And I've been in Accenture for around 5 years now. And in that, I've been working on blockchain for the last 3. Yeah, so that's my introduction, and I'll now go through the architecture, which is the next slide. So that's, yeah, Priyanka, if you can. Yeah, thank you. Yeah, so this is the DLT reference architecture. I see a question there, but this is the DLT reference architecture. It has, I think it was open sourced a year ago from Accenture, and it covers tries to cover all the architecture aspects and how in blockchain automation framework, this is how we have implemented it. And as I said, so it's a DLT reference architecture is a reference architecture, so you can have multiple versions of the implementation. It doesn't have to be this way, it can be done any other way, but of course the main boxes that you can see here has to be addressed. Yeah, so just starting from the left hand side, we have the security services and the DevOps services. So that's the blue highlighted. The security is kind of more development and operations. I mean, it's also part of the runtime architecture and not just development. The DevOps services are the DevOps only for the development environment, of course. And of course, the whole green area that you see is the runtime and the execution architecture. So how BAF does it is we use Git for the policy and version management. We have Ansible and for the configuration, and for Kubernetes, we use Helm. And we have the build and test environment using Travis Jenkins, as well as GitHub for the artifact management, and the delivery management via GitHub, because all our issues are tracked in GitHub. And read the docs is our documentation. So if you guys are able to go to our main project link, you can have all the links to our read the docs there. And from the security point of view, we used Vault, HashiCorp Vault as the key management, key and certificates management. And it is why we use Vault is because we wanted to, again, not tied to a particular cloud provider. So Vault is can be deployed on any cloud, and it has right now it has integrations with the usual the popular cloud providers like AWS and Azure and Google as well. But we've used Vault instead of like any key management service from the cloud provider, so that we can port it to another cloud provider easily. So it gives us that abstraction. Then coming to the infrastructure services, is the same. The cloud providers are can be any, as long as they can host Kubernetes or EK or a managed Kubernetes. And again, here as well, Kubernetes gives us that abstraction so that the network can be deployed on cloud on-premise as well, if you are using and you can use OpenShift as well. As long as Kubernetes can be deployed, our platform can be used on top of it. And the distributed data platforms, we are providing support for, so already published are Fabric, Corda, Quorum, and Indy. So we are working on Besu and Enterprise Corda right now. And then on top, you have the integration services which are provided by Ambassador. And everything else, as you can see, is either out of scope of the automation framework or to be done by the application. So any, because for example, the presentation services, data services, and application integration, all these will vary on the application and not just the DLT platform. So that's why they are all like TBD kind of. But this is how it looks, and I've created this green box for all the prerequisites. So for our platform, blockchain automation framework to work, the Vault is a prerequisite, as well as the cloud environment and the Kubernetes cluster. But as I said, it can be EKS or Azure or GCP cluster, GKE basically. Yeah. That's for now. Any questions which are burning, which I can take now on the architecture?
So Shaunak, there is one question on, is the architecture exhaustive?
Exhaustive in what sense? Like, can anything else be added to the architecture? Yes, I don't think it is exhaustive as. So I mean, this is I think the main, the big boxes that you see, like the security services, DevOps services, presentation, integration, and all. So those, I guess, are exhaustive, unless you can add anything else. In my review, I don't think there is anything else can be added. But whatever is after inside you put in the integration services, that is not exhaustive. You can have any other integration, right? You can have your microservices and all. But this takes care of that microservices architecture as well. What is Ambassador? Yeah, so Ambassador is a egress load balancer. So how we have used, so basically our clusters have to talk to other clusters, because from our design, it is each organization should host their own nodes or peers in their own cluster, and organizations should not be sharing clusters, because that's the concept of organizations. So how they talk to each other is via this Ambassador URLs or Ambassador. Ambassador is a software which is kind of like it works as a proxy. Internally, it uses Envoy proxy, but it gives a bit easier way to manage your Kubernetes services. It's the enterprise bus, actually. That's all. Ambassador creates a cloud load balancer. So Ambassador is not anything new. So if you deploy Ambassador on AWS, it will use AWS load balancers. If you deploy Ambassador on, it is deployed on the Kubernetes cluster itself. So Kubernetes deploys the load balancers on, if you're deploying on Azure, it will use a Azure load balancer.
So there have been some questions on, with R3 Corda. Yes, we would do that, but the session today, we are taking you through the Hyperledger Fabric deployment. We will be having another meetup, and yeah, please be on a lookout. We will be doing R3 Corda next as well.
Yeah. And coming back to, I think there are more questions on Ambassador. I mean, you can always go and search what is Ambassador. But Ambassador, in summary, it is deployed on Kubernetes. So it is not anything separate. So it is deployed on Kubernetes, and you have to have access. Yeah, so each one Kubernetes cluster will generally have one Ambassador. You cannot have multiple. And all the inter-cluster, basically that means all the traffic that is coming from outside the Kubernetes cluster is routed or should be routed via Ambassador. Yeah, and it will work on on-premise if you have on-premise Kubernetes. Next, I don't think anything else. I've missed any other questions. If yes, we can relook at the end of the session.
So some questions are on the version. So, we currently upgrade the version, Hyperledger Fabric version that we support, and currently 2.2, not yet, it's just released. So, and we also kind of wait for Hyperledger Fabric to announce that it has the production readiness, and only then we bring it to our roadmap. So, and in fact, we are very open if somebody wants to do it for us. We'll create an issue, we'll assign it to you, and you can just work and become a contributor and make it compatible with the next version, right?
Yeah, can go to the next slide.
So on Ambassador, there's one more question, Shanak. If maybe we can that why didn't we use ingress like Nginx and a preference for Ambassador?
Oh, preference for Ambassador is because Ambassador configuration is much easier to do. For Fabric we use HA proxy. I don't know, it's missing from here. Yeah, but we use HA proxy. But both are similar. So why we chose HA proxy or Ambassador is that for doing the configuration, because we keep on adding new stuff, like we keep on adding Fabric and Corda and Quorum, and then we keep on adding different organizations in our networks. So what advantage it gives is Ambassador and as well as HA proxy. Once you have configured it for the cluster, you don't have to change it. So Ambassador, all the ingress can be created, but by just writing annotation service on the services, on the Kubernetes services. And for HA proxy, the ingress can be created by just creating the ingress objects in Kubernetes. So you don't actually touch the deployment of Ambassador or HA proxy for doing any changes. For using Nginx and all, so every time I want to add a new platform, maybe it will be similar to adding an ingress, but Ambassador is much easier. So initially we chose Ambassador, then we have problems. We had problems for Ambassador for Fabric because Ambassador doesn't do SSL pass-through. So as a result, we had to use HA proxy for SSL pass-through because our Fabric network is anyway TLS secure. So we don't have to put it on another TLS via Ambassador.
And on the same note, I would like to add that, if you have a architectural suggestion or a tool suggestion which you think will be a better fit, and please come on our open plannings that we do, and we would love to hear from you. And and why not
and
do
BAF
it for better?
Yeah, not Accenture specific. It is open source, so anyone can use it. There is nothing Accenture specific in there. It's as much as Accenture specific as Fabric is IBM specific. Yeah, so Fabric, so this is how we did it. for automation of Fabric, because this session is for Fabric. If you go to our main documentation, you will have all the similar diagrams for Quorum and Corda, Besu as well, which is in progress. So yeah, so we have the Docker images. We use the Docker or whatever Fabric has published. You can use your own personal, your own private repository as well. We have made that provision. You don't, doesn't have to be the public Docker Hub. And then we have the Ansible, which is the main configuration management tool that we use, or is the only configuration management tool we use. And so the developers will basically edit a network YAML or a config file. We call it network YAML generally, and then give that as an input to this Ansible automation, and then they will get the network. So in Ansible, we have all these separate playbooks or roles created, which will do order setup, node setup, chain code installation, and all that, creating channel. And then what it will do is actually use Helm releases. Helm is a release management for Kubernetes. So we have created Helm charts for each of them, these as well. Like we have created a Helm chart for updating a chain code, deploying a chain code, joining a channel, creating orderer with Raft or Kafka, and a peer node, and all that. And so using that releases, it will deploy into Kubernetes. And an additional thing is that we have continuous delivery kind of inbuilt in our solution by using Weaveworks Flux. So we have Flux is Flux is basically uses Git as your configuration repo. So all the Helm files will get checked into a Git repo, and from there Flux will deploy into the Kubernetes cluster. So why we did this is that, so just to coming back to full circle on why it is continuous delivery in such a way. So if you have one Kubernetes cluster for your one development environment, and you have set up your Fabric network on that, and you want to do some changes, for example, just change the version of the chain code and all that, what you can do is just check in or do a pull request to that particular branch which is synced with Kubernetes, and it will automatically, Flux will pick it up. And why we did this is we treat Kubernetes itself, the whole cluster itself, as mutable, in the sense ephemeral, which means that even if the Kubernetes cluster is completely deleted, you will still have the configuration of the Helms in a Git repository, from where if you install the install again on the Flux, etc., and then it will deploy all the things that was in your previous Kubernetes cluster in the new Kubernetes cluster. Yeah, so that's the general. That's another, like, we already have Kubernetes continuous delivery inbuilt in this. Okay. Any questions on this slide we can take, or how are we doing on the time?
Yeah, I think we are doing good on the time. One question which might be related to this one is, do we support adding new orders once after the consortium is set up? If yes, will it just onboard to system channel or application channel as well?
No, we have not tried it, but yeah, you can try it. It may work out of the box. It may not, may need some changes. Yeah.
So for a lot of questions here, I see some similar questions. Folks, one thing is, if you could come on our GitHub project board, just open an issue, because that gives us indication that there is a demand for this feature. People want to see this. And if you can do it with us, well and good. If not, we will pick it up in our planning. So
yeah, you can create, anyone can create a feature request on our GitHub issues board, and you can first search if that issue has been created or not. And if you found the same issue is already there, you can just do a upvote on that. So we can track that which issues are getting more attention.
Okay, moving ahead.
Oh, demo, right? So let me share my screen now.
Yes, Shanak, I stopped sharing.
Okay. Yeah, so hope you guys can see my GitHub. So that's the link that was in the presentation, as well as in the, so this is our GitHub link. So our Hyperledger Labs blockchain automation framework and everything is here. As I said, mentioned, all the issues are here, and our current sprint that is going to end on Monday, early Monday is here. And this is our code. I mean, generally we do keep the master branch updated, but all the latest things happen in develop. And yeah, so from the demo point of view, I will take you to the platforms. First of all, I'll show you the network YAML, which is the main configuration file. And then I'll show you a video of how the demo works, how it kind of executes and all that. So so we have, from a code structure point of view, it is under, everything is under platforms. So your main code for each platform is under platforms. We have two examples, one for the Corda and everything, and one for Indie. These are example apps to prove that whatever you have done is correct. It works basically, because unless you make a transaction in a blockchain network, you cannot really say that it is successful. Docs is just our read the docs repository, so as code, so you can but you can always go back to the read the docs to actually just see the docs. And the automation is basically the Jenkins file, because we internally in Accenture we use Jenkins to do our CI as well as CD for on a AWS cluster. So that for that I will just we have this Jenkins file. Yeah. So platforms can select, we have to select Hyperledger Fabric, and how each of the platforms are kind of divided is, we have all the Helm charts in charts, we have all the Ansible and related code in configuration. Any kind of configuration code is in configuration. Images, it will be if there is any custom Docker image. For Fabric it is empty, because for Fabric we don't use any custom Docker image. So all the Docker files would have been here. Releases is basically for the GitOps using Weavework, so it is empty. But for your release direct, when you make a release, when you do a deployment, you should have files in this directory in that particular branch, not necessarily master branch. And scripts are any scripts that we may be using. So that's the general, and our sample configuration files are provided in configuration samples. So I'll just go through the Raft one, because I think Kafka is not kind of unsupported now. So in Fabric, so this is how it looks. We have the network. So in generally it will always look as for each platform it is similar. Of course there will be little bit customizations, because Corda is different from Fabric and Fabric is different from Quorum. But we have the similar structure. Network type is Fabric. The version, it's also support, I mean it's not updated here, but we also support 2.0.0. It's not added in this example, but it is added in our documents. We have the front end. This is only specific if you are deploying the supply chain application. Otherwise, it can be ignored. And then we have this section for the environment type. So if you have multiple environments, you can run them on the same cluster. You can run them using this, or you can just do production and all that. So as I said, proxies, HA proxy, it can have ambassador, but for Fabric, the ambassador doesn't work, only because there is no SSL pass-through. If ambassador supports SSL pass-through, we'll be again coming back and trying to implement using ambassador. So this is only relevant for ambassador anyways. Retry count is in our so basically the playbook, when we run the Ansible playbook, it will wait for some events to happen, like a namespace getting created or a storage class getting created. So this is the retry count for how long that event will wait, or how many times it will retry. So basically to give you an enable you to, if you have a slower network, then you can increase it so that it retries for longer. And external DNS is used so that you can update your the load balancer, the route 53, or your so it is connected to for AWS it is route 53 or the DNS provider, so that all the calls are made via, for the load balancer it is made via the domain name that you have used. It doesn't have to be, you don't have to use the IP addresses. And as I said, you can use your private Docker hub, or even your, say, Azure Docker registry here, all the details here, URL, username, and password. And then we have the orderer sections. So this is a raft consensus. So we have 3 orderers, and each orderer, we have the URI, which is the reachability, and this is the URI that will be updated using your external DNS configuration. So basically, you have to add in your DNS that star.org1ambassador.blockchaincloudpoc.com should direct to your ambassador load balancer IP address. Then we have the channels. Channel description. So we have the example channel, because this is an example for the supply chain app that we have provided. So it's kind of takes care of that. So we create a channel called all channel. We have the orderer names and the participants. And of the participants, one has to be creator, who will be mainly doing like the creating the channel and then instantiating the chain code and all that. Everyone else can be a joiner. Yeah, and then we have the organizations. So ideally, in ideal scenarios, only in one configuration file, you should have only one organization, because the concept is that everyone is maintaining their own Kubernetes clusters. But for in our example, as well as in the test, generally on the test environments, you will have only one cluster to test out, or maybe just 2 clusters, but you'll have access to both the clusters from the same machine, because they are in your environment. So we have multiple organizations hence. Otherwise, in a real production scenario, you will only have 1 or maybe 2 organizations which is hosted on that particular cluster. So organization details, the subject kind of for creation of the CA certificates. And this is the external URL suffix that I said. So this will be updated in your in the route 53 so that it marks there. And we have this org status as new or existing. So existing is used when you add a new organization. So we have not tested addition of a new orderer organization, but we have added a new peer organization. So for that, you can use existing when you are doing add. There is a separate configuration sample for adding of a new organization, but for generally when you are starting up, your org status will be new for everything. And then the CA details, we are using Fabric CA. So if you don't want to use Fabric CA and you have already all the certificates, you can remove this section. And also in that case, what you'll have to do is put all the certificates in Vault in their paths in HashiCorp Vault. Cloud provider wise, it's Azure, GCP, or Minikube. So if you can try, if we have run some workshops which we did on Minikube, so it's supported you can work on Minikube, but it takes a lot of memory. So unless you have a lot of time and a lot of memory in your computer, yeah, I would not suggest to use Minikube. Then the AWS access details if you are using AWS. So as we have only, I mean, we have completely, from our point of view, completely tested on AWS, but it has been running on Azure for few clients. So in that case, you'll have to most probably change a bit if you need accesses. Then comes the Kubernetes section. So here you are providing the context of the Kubernetes and the Kubernetes config file. So this is how you can do, you can still have a single configuration file, but you can have multiple contexts in the same configuration file to connect to your Kubernetes cluster. Then this is the vault, which is the vault address and the root token. We use the root token because when you create, when you deploy, at the first time you will have to say authenticate Kubernetes with HashiCorp Vault so that they can do the token exchange. So Vault root token is used, but the Vault root token can always be recycled. So for example, in a production scenario, after you have done your first deployment, the root token may be exposed somewhere in the logs or anything. You can go and delete the old root token and create a new root token. Vault gives you that access. Then this is the GitOps section, which is basically Git files, Git repos, repo details, like which Git repo it will check into, which branch it will check into, what is the release directory, what is the charge directory, and this is push, and we have the private key as well, the SSH for using Git as SSH. And then finally, we have the services section. So this is so rest of the sections are kind of similar for all organizations, but this services section will be different for orderer and peer organizations. I'll show that. So the CA details are here. As I said, if you don't want hosting a CA, you don't need to put this. Then we have the consensus, which is the choice. It can be for Fabric, it can be Raft and Kafka. And then the orderers, which is the number of orderers that you are hosting. So if we move to the peer organization, this how it is different is that you will, instead of orderers and Kafka and consensus and all that, you will have peers. So the CA part remains same, but you can have multiple peers. In our example, we only use one peer, but we have tested, like if you just copy paste it into another peer with a different name, you can create it as another multiple peers in the same organization. And then we also have the anchor peer tag here. So if you say non-anchor, it will not become an anchor peer, but if you say anchor, it will be the anchor peer. And all the ports are here. And also the chain code, you can deploy the chain code from here if you want to at this time of deployment. You can also do it separately, because we have a separate playbook to do the chain code. So in that case, you will also provide the chain code details, the chain code repository. So the advantage here is that you can use a separate path for your chain codes. It doesn't have to be this repository. So you can give that URL here. And that username password for this one, and your chain code will be deployed directly from the Git repository. Yeah, so that's pretty much, and then it all gets repeated for each organization. So in this example, I guess we have 4 organizations, 4 peers and 1 orderer, so 5 organizations in total. That's the summary of it. Okay, any questions are there, Priyanka? Burning, it's popping up, but anything which needs to be answered at this moment, which is relevant to this YAML file?
So I've answered few of them. One question is it really required to provide Git credentials for Minikube? And if not, then provide Docker Hub credential, whether it will work. So,
sorry.
So is it, I think Kiran has this question, is it really required to provide Git credentials for Minikube?
Is this related to GitOps section?
I don't think so. I think Kiran might have navigated to the Minikube section of our documentation. And so okay. I don't know if we can, so Kiran, if you can just type in and confirm your question.
So, as I'll answer preemptively anyway. So if it is GitOps, yeah, it has to be given for Minikube as well, because as I said, the CD is inbuilt, continuous delivery or continuous deployment is inbuilt. So you have to check in those files into a Git repository for that to work with your Minikube. or Kubernetes cluster, any Kubernetes cluster, be it Minikube. But again, we have kept on constantly saying this, I think in other workshops as well, it is more difficult to get BAF running on Minikube than it is to get BAF running on a cluster because of these complications, mainly around the access of, or like Ambassador, you cannot deploy a load balancer on Minikube, for example. So because of those things, and BAF is created for production or pilot environment and not really for Minikube. Yeah, but the summary of this is, yeah, you have to provide this details here. And if the question was around the Docker Hub credentials, yeah, you can, even if you're using Docker Hub like here in Hyperledger Labs, you have to give a Docker name password because we create the secrets. We have not yet separated them out like with the if else condition. But I mean, I think even if you give wrong username password, it works because Hyperledger Lab, it doesn't necessarily, if you pull something from Docker Hub, it doesn't need username password. But we have not tried it. We always give the dummy username password, which is a generic username password we have created on Docker Hub.
So one more question is, do we supply a separate Kubernetes script for container management, or are they automatically created from Ratchet?
I'm sorry, automatically created from?
Yeah, that's I think the question is more on the cluster creation, the container creation, and the script for that.
Okay, the cluster. So cluster creation is not part of BAF, as I guess Priyanka mentioned. The cluster, Kubernetes cluster creation is out of scope of BAF because the Kubernetes cluster itself is a prerequisite. And container management is provided by Kubernetes as far as I know. So Kubernetes gets the containers and deploys it. And we have used the Flux as well. So basically Flux also detects, image changes. So for example, you are using Fabric CA 1.4.4 and from the Docker Hub. And tomorrow someone updates the Fabric image 1.4.4, Helm will detect it and it will download the latest. Not Helm, Flux will detect it and it will download the latest and to redeploy your application with that. And yeah, and if you're getting scared, okay, my pod will get killed and it will fail everything. It won't, because we are using PVCs, persistent volumes, for all pods for everything. So I mean, whatever is which needs to be persistent. So Kubernetes should schedule it accordingly. So the pods get the new pod will get the older persistent volume. So you will not lose your data. Plus orderers will have their own, so they will communicate and build up your chain again. Okay.
So one question is, does BAF support peer recovery? I don't know if it is discovery or recovery. So Shaunak, yeah, do you want to take that?
Peer recovery.
When they go down, yeah, I think that's what.
So peer goes down. So I mean, in BAF, everything is a Kubernetes pod. So all your peers is Kubernetes pods. Are Kubernetes pods. So if a peer goes down, it's the responsibility of Kubernetes to ping it up, because Kubernetes knows that the pod is sick. And as I mentioned, from the the data point of view, yeah. So we have used Kubernetes to do PVC. I use PVC, so it will get its own information. Plus the pods, when a pod starts up, it gets the exact same certificates as the previous pod was when it got killed from Vault. And so it will connect so if peer 0 goes down, it will always connect as peer 0 when it comes up again, and it will have all the links to the orderer and all, and the anchor peers and everything, and should build its own chain or its own local database. automatically. Yeah. So I don't think it's a BAF. We have, as I said, it's not a BAF kind of requirement, or does BAF support this or that. It's more of a Kubernetes requirement. We have used PVCs, so it should do that.
Yeah.
And we have tested it as well.
And to answer to Arnab, his question is the network set up via YAML only, or do you have an API first approach as well? So Shaunak, I mean, I don't think
No,
we
it
have,
is,
yeah.
yeah, it is YAML only, because it is, so from a, what should I say, from a user point of view, BAF is targeted for DLT network operators. So it's an operations tool. So an operations person will deploy the network and will deploy the chain code or will add a new organization, right? Or will upgrade the fabric version, for example. We have not done that yet, right? From going from one version to another. So yeah, so it is a good challenge. You can take it up, but yeah, so that's maintained from there. So there is no, it's taken from the network YAML format only. So idea is that if I'm running a production network, I will have my network YAML ready and securely saved somewhere, yeah, encrypted and all that, because it has a lot of sensitive data, and then I'll use that to do my network. So yeah, so there's no API, it's not API based.
So one more question is, how do we authorize a Kubernetes cluster with BAF?
How do you authorize? What does that mean?
So,
I mean, how do you,
yeah.
from BAF, how do you connect to Kubernetes, or?
Yeah, I think so, Shaunak. Maybe, yeah, you can answer to that, and I will keep an eye
Yeah,
out
so
for that.
the answer is using the Kubernetes config file. So as long as, so from AWS, so we have only used managed Kubernetes solutions to test this. We have not used vanilla Kubernetes. But it's almost similar, I guess. So you have a Kubernetes config file, which gives you that specific rights to connect to the cluster. So you use that config file, and that path to the config file is provided here. So when running this playbook with this network YAML, you have to update this path with the absolute path of that config file. So generally in AWS, you can use the config file with AWS roles by using the assume role thing. But for GKE and for AKS, it can, all the secrets are contained in that as a public keys. So, or certificates, so you can connect if you have the config file. Yeah, so it is imperative that you save the Kubernetes config file in a secret environment.
So Shaunak, I think in essence of time, we should go for the demo.
Yeah, I mean, the demo is not, I mean, that big, but anyways, yeah. So, I mean, I guess the more important part was to show that how these configurations can be done and answer those questions, that you can do those configurations. Of course, when you try to do it first time, you may encounter some problems. That's why we are trying to improve our documentation in more detail. And as well as, I mean, what we have seen, we have run a lot of workshops as well as deployathons, one deployathon, not a lot, but we have run workshops where the main criteria is getting the prerequisites right. Once you have the prerequisites right, which in this case is your vault and Kubernetes cluster and the Git repository, then everything is quite smooth after that. Yeah, so I'll share my video now, so that this is how it look when you deploy. It shows, it's not like it will I have kind of what should I say, fast forwarded it in bits and points where it is important. So can you see my screen?
Yes.
I think the video quality is quite bad because I did just do it using Adobe. Let's see. Yeah, so this is where it starts. I think the, just a minute, I think it started too soon. I will. Can you still see my screen?
Yes, Shanak. So
Yeah,
it's cursor is at Ansible playbook.
yeah. So this is where the Ansible playbook command is getting executed. So you give the site.yaml, that's the main playbook, the master playbook that we have. And then we pass as -e is an extra parameter, the network YAML file, which in this case, the name is multi-peer, multi-orderer YAML. Yeah, and that's it. It just does that. And then the first of all, it tries to install all the Kubernetes, all the clients and all, like Vault client, Kubernetes client, and then it installs Flux. So as you can see on the right is the Flux pods coming up on your Kubernetes cluster. So once the Flux pod comes up, that is where it is basically syncing a particular Git branch to your Kubernetes cluster. And then gradually the namespace get created. As you can see, when we do the Kubernetes get namespaces, so we for each organization we create a separate namespace so that they can run on the same cluster as well. And these are Kubernetes namespaces. And then the CA servers and the tools are running. As you can see, it got from pending to init to pod initializing to running. So we have the CA tools, CA servers, and then the CA tools to be deployed. And every time we see, if you see on your left, there is this failed retrying. So that doesn't mean that it has failed. It has retrying, and that was the retry count that I mentioned earlier. So it will try for 20 minutes and it will check 20 times and check. Yeah, and then we generate the crypto using our files like generate user crypto and generate crypto.sh on the CA tools and write those crypto into Vault. So there is no crypto gen. So why we did this is that so that you don't have to share the crypto materials between organizations. So each organization can have their own crypto materials. Yeah, then after that the channel and all those are created, and then the pod gets created. Sorry, the peers and the orderers get created, and as you can see on the right now, the peers and orderers are getting created, and they have their own. For example, the peers have their CouchDB attached to them, so that's why you have the number of containers in the peer is 2. And this example is for ZK Kafka, so that's why you see the orderers Kafka pods also getting created. And then finally we have the channel creation. The channel gets created depending on your network configuration, as I said. And as you can see it, oops, I should not move my cursor. So it will update the channel, and then it will then wait for join channel. And then as you see, you can see that the join channels were created for each peer 1, peer 0, and then the anchor peers were updated. So we have used only one peer as anchor peer. The peer 1 is the anchor peer, so that's why the jobs for anchor peer is say peer 1. Yeah, so all our jobs, so the channel update, joining channel, creating channel, join up, and joining channel anchor peers are jobs on Kubernetes. And then after that we do the install chain code. Again, it's a job for each, which runs on each peer. So installation of the chain code, and as I said, it installs the chain code or gets the code of the chain code directly from the Git. And then after that we are waiting for, it will wait for that so that these it waits for instantiation of the chain code, and that is the final thing. When it is basically when you say instantiate chain code, you complete everything. And if you finally do get pods, you'll see all the, just pause here. Yeah, I mean, it's the end of the video. Anyways, so I'll, so for each namespace, so CJ is one namespace and MJ is one namespace and SJ is another. So SJ is the first, the order organization, which is hosting these orderers and Kafka and Zookeeper nodes, and also the CA tools. And then CJ is hosting 2 peers and MJ is hosting 2 peers. And then for each of them, we also have the anchor peer was updated, the channel was created, and the channel is created from only one peer because you don't need to create channels from all. Then we have the install for each peer, peer 0 and 1, and then we have instantiation from only one peer because you don't need that for multiple peers, and join channel for each peer again. So same thing is repeated here. The only difference here is that there is no create channel in MJ and there is no instantiate in MJ, but otherwise it's they're the same. And these are the jobs. So whatever is completed are the jobs. That means they have completed. Sometimes we have seen that there are issues with network or something and it gets the job. So for example, your join channel request doesn't work first time. Yeah, so we have all a count of 6 in each of the jobs. So it will retry for 6 times. And yeah, even if it fails, then it will go delete. Actually, you have to catch it if it were the failure reason within the 6 times. So it will retry for 6 times to create the channel or install the chain code or instantiate the chain codes. All jobs are like that. And but whatever is running are just pods or your servers. So they are running and you can log into them similar to your Docker containers and you can check their logs. Yeah, so that's all.
So Shanak, one question from Clyde is that to be able to deploy to infrastructure of multiple orgs, this framework would need access to the infrastructure. Where is that gone? Sorry. To the, each org's infrastructure. So how do we ensure that each participant has complete control over their own, their private keys?
Yeah, so as I said, from an operations point of view, each organization will have their own Kubernetes cluster, right? And their own vault. So when you could deploy, and the only thing that will be shared between the organizations is the orderer public certificates, right? Because otherwise, without that, they will not be able to connect. And the peers will not be able to connect. So that's the only thing that will be shared. So from a hypothetical production point of view is that the first network to be set up will be the orderers. So once orderer is set up, like Raft, 3 or nodes and all that you have set up, and then you know the certificates, all the certificates will be stored in the orderer's vault, and only whoever has access to that vault will be able to see them. So you share those public certificates to the peer organizations. The peer organizations then write their own section, own network YAML without the orderer organization, their only own organization. And yeah, they have their own vault and their own Kubernetes cluster.
Okay, I hope that answered because I saw multiple folks had questions similar to that. The next question is, I'll just do away with the, is there any front-end demo? No, not today. We're not doing a front-end demo because the front-end is basically pluggable, right? Our focus is not on the application on the front end. We do have a supply chain reference application, which is also open sourced, but it is basically for us to be able to, do a demo to folks and make it more understandable. But essentially what we want to showcase is how the network comes up, how it gets deployed, and how the automation is being done to make life for the application engineer or developers much more easier and maintainable. So there's another question. The pods created for chain code installation, what happens to them after the chain code has been installed? Does BAF take care of those extra pods by itself?
The pods, I mean, Kubernetes, it's the pod. Whenever a chain code pod is complete, it is complete. It just stays there until, so it's not there. So whatever task, whatever pod you see as completed is not actually doing anything. Yeah, so it's not taking any memory or anything. It's just there in the etcd file. So next time you downscale your Kubernetes cluster and upscale it again, the pods will go, those pods. They don't take up anything. I think there was a Kubernetes issue. I'm not sure if they have solved it, so that we can do away with the pods with the tag that it will go after completion, after say 2 hours of completion automatically. But I'm not sure if it is there in the current version. We have not tried it, but it does get deleted if it fails for more than 6 times. Yeah, and there was a question about I got insufficient nodes error. So sorry, that insufficient nodes error generally means your cluster is not sufficient. So basically, the AWS, the EC pods are not having. There is a limit on AWS EKS, I think, with the number of pods depending on the EC2 instance type. I mean, it's limit on for everything, but for basically for AWS GKE as well as AKS. So there is not anything new. What you have to do is just add another node to your auto scaling group.
So Shaunak, there was another question on Vault, which I answered that, Vault is a prerequisite. It has to be up and unsealed.
Mm-hmm.
Yeah. So do we need to bring it up separately is another question.
Yes, I mean, in the sense, it has to be separate. The Vault is not inside the Kubernetes cluster. It is outside the Kubernetes cluster. So you can run it on the Kubernetes cluster, but at your own risk, because as I said, we treat Kubernetes cluster as ephemeral. So if your Kubernetes cluster get deleted, your Vault also gets deleted and sealed. Generally, you will not use an in-memory one. I guess you will either use an S3 bucket or an EFS when you run, Elastic File System to when you deploy Vault. So the files will stay, but your Vault front end and the access will be, the service will be lost if you are running it on Kubernetes and the Kubernetes is down. You can run, we in our environment, test environments, we run Vault behind in private subnet with a bastion access and a tunnel created for access. Otherwise, Kubernetes has access to it. Yeah,
Okay.
and you have to deploy it separately.
Okay, so another question is CAS enabled for multi-cloud volumes?
Sorry, what is CAS?
I think something to do with client access, if I'm not wrong. So Prakash, if you could just, be a little bit more elaborate on what do you mean?
Cloud.
Yeah.
I think I saw somewhere CAS. Is it for deploying different storages? Yeah. So one thing is that that will deploy. I think what I understand that it means you are going to use say EFS instead of the the persistent volume that is provided. So that will depend on the Kubernetes cluster, I think. Yeah. So that will depend on the Kubernetes cluster. So it's not. We have not tested it. You can try that out. Everything for us is tested on AWS or AKS or GKE on the default storage class that they have provided, though we create our own storage class, but from the available classes that are already there, like GP2 or general for GKE. Yeah.
Okay. So another question is, how do you connect the peers? Is it over cluster IP or node IP?
How do you connect the peers? So connection between internal peers is through internal services, right? So if peer 0 and peer 1 of the same organization will connect using say peer 0 dot abc /net, which is the namespace, or in our case this sj dot /net -net colon 7051 or something. And for intercluster, I mean, it generally connects via the it will connect via the ambassador addresses. So yeah, oh sorry, I keep saying ambassador, is HA proxy in this case. So basically the proxy addresses. So it will be say org1 ambassador.com colon 8443 or whatever. Yeah.
Okay, so some other question, can we deploy it on local environment? Yeah, the Minikube is for that purpose, right?
Yeah, Minikube is not a local environment per se. It is a test environment. I mean, dev test environment. So if you want to run on a local environment, I think it's better to just get a server and run Kubernetes on top of it.
Yeah, okay. And Gautam asks, are you referring to keys when you say crypto?
Yes.
Yes.
Yeah. When I say crypto, it is all that is generated by your CryptoGen tool in Fabric. So the MSP certificates and keys and yeah, so certificates and keys.
Okay. So next is how we guarantee for CA in automation framework is reliable, because
Yeah, so
certificate
we don't
authority.
guarantee. So we don't guarantee CA in automation framework is reliable because Fabric themselves don't guarantee Fabric CA is reliable. So please use, for production networks, please use a proper CA with correct root certificates.
Yeah. And Shanak, do you...
And yeah, and then just to add to that, then you can store that all the certificates you generated in the paths which we have in our documentation on in Vault on those particular locations. Yeah. Yeah.
So Shanak, do you know what is Puppet? Because one question is that, is this automation framework comparable to Puppet for Ethereum? Are these for same purpose?
I'm not sure of Puppet, but yeah, if Puppet is open source, then maybe, and does the same thing, maybe it is comparable.
Yeah, but again, to reiterate, right, a lot of clients don't want to use Ethereum because it's not a enterprise distributed ledger.
Permissionless.
Yeah, it's permissionless, right? So what we have here is something that can be taken to a client for an enterprise blockchain implementation.
Permissioned.
Yeah. Okay, I think we have answered most. So there's one question from Amol. He asks, let's assume there are 5 orgs in a network, some with peers, endorsers, and some with orderers. Is BAF supposed to be used separately by each organization on their own to deploy components according to their role? And agreement on who does what, how many peers, who creates the chain code, etc., is out of scope of this tool and off band is his question.
Okay, so in a real ideal world scenario, right, which is not there, that each organization maintains their own network, right? So an orderer organization is hosting only the orderer, so they will use BAF to host it. Another organization is hosting a peer organization. They may use BAF for hosting, but may not use BAF for hosting. It's fine. And then another third organization is hosting another peer who also uses BAF for hosting. So that is separate. So they can maintain their own cluster, own peer configuration in that. The only thing, as I said earlier, they have to share between the peers is the orderer certificates, right? Because otherwise, without the orderer CA certificates, they will not be able to connect to the orderers. Okay, and then agreement on who does what, how many peers. So how many peers is depending on the organization. So if organization was saying I'm going to host 3 peers, they can very well do so. And of course they have to host at least one anchor peer, because from that anchor peer they have to connect. Or that is anyways not BAS specific, it is Fabric specific. Who creates the chain code and all? Yeah, so the chain code depends on the consortium, right? So if the chain code gets, the channel itself also depends on the consortium. So of course they have to agree. As I said, for the channel creation, there is a creator organization and all others are joined. So they have to agree that, okay, I will be the organization A will be the creation of the channel as well as the instantiation of the chain code, because those two are the important things to be done. Yeah, so but the chain code installation anyway has to be done by each of the organizations. So all that management, those are all consortium management things, right? It's not, you cannot put them in a tool. Yeah.
And Rachit, you're right. We right now have not open sourced the code which we internally use basically to create a Kubernetes cluster. Uh, we are deploying on existing service. That's right. I mean, again, if this is open for contribution, if you really want to create those scripts and the reason why we do not want it to do that is that we wanted to keep it as agnostic, and for everything to test everything we will need an infra, right, to host it up. So but yes, you are if you want, you're interested, then please come and contribute.
Yeah, so we kept the separation of concern for the infrastructure and the DLT infrastructure. So the bottom, the cloud infrastructure, which is the new hardware, right, is out of scope, because it's as a prerequisite. So we have not, because every organization will have their own way to do it. Someone will use Terraform, someone will use CloudFormation, and we don't want to guide that, and they will have their own security concerns on that, right? So we don't want to do that. That's why we have not done it. Yeah, so that's the thing. We are, I mean, you can always go to CloudFormation, I mean, and check if there is any tool to set those things up. And how is different from Cello Cello is for front end, I guess. And as well, I guess Cello is, I've not tried to use Cello because it's very difficult right now to understand. But it's not entirely different from Cello, but yeah, Cello does have a nice looking front end and all that. And it is not only focused on Kubernetes. I think the idea of Cello is that it is it can be used for using Docker as well as VMs and all. And it only right now supports Fabric. So the difference between that is that we use only Kubernetes and we have support for multiple platforms. And we don't have a front end, which means creating an automation is automating it is much easier. Like if you have to create even 10 organizations, it's much easier to automate using BAF than Cello, I guess, because in Cello you have to do it from front end. Yeah, and I think there is other questions in the chat as well, like if you can host just order. Yes, of course you can just host an orderer. Yeah, I think we've answered all.
Mostly, yes. So in the essence of time, we have just, I guess, 10 more minutes, a little, yeah. So what we also wanted to share with you is the roadmap as it looks currently, and we do get driven by the demand for features from the community as well as the clients that we speak internally to. So for example, now what you see is that we are working on R3 Corda Enterprise version. So we already have the Corda open source, but we are working on R3 Corda Enterprise version because we felt that demand. We got a lot of market input on that. We are also doing base supervisioning. So these two things are the current work that is going on. Along with the tool upgrade, which is Helm 3. We are also upgrading from I think 1.14 to 1.16 in EKS, and also targeting Hyperledger Fabric upgrade. So but this is this keeps changing. For example, we had Sawtooth here on the roadmap a few months back, but right now we did not. We kind of it faded a bit on the demand, so we deprioritized it. So if you have some feature demands that you yourself feel, or you have clients that you talk to, and then please come to our board and raise a feature request. We would be glad to prioritize that. So with that, I'll go, once again share the deck that I was sharing. So we just finished a roadmap, and the last thing that we wanted to give some time is, we would really want you to get involved, and we are happy to see so many questions around what we are doing. We have tried to make the documentation as exhaustive as possible. But if you feel that there are parts missing, please come on our board and raise an issue that, this part of documentation is not clear, and as a bug, and we will be happy to work on that. We also want you to, kind of come and collaborate with us. You can maybe, come up with an additional platform and say that, hey, why don't you enable this platform for us? Say, for example, why don't you enable Sawtooth for us, because we are working on Sawtooth right now. Similarly, if, for example, there is a tool that you feel would be a good fit and could be integrated with BAF to make it a more complete solution, then please come up with those suggestions. We have our planning. It exists, on Hyperledger calendar. If you go to Hyperledger calendar and if you search for Hyperledger Labs, we have, for example, we are having our next planning on the coming Monday. So we will be really happy to see if you want to propose some of those things. The third would be, if you have, we want, our focus on BAF was on architecture. We wanted it to be, to have the architecture which is production worthy. So if you have any suggestions to make it better, we would love to have those suggestions, and add it in our roadmap, create issues out of it, and to work on them. So please do that. The last thing is, some of you might be implementing some Hyperledger Fabric or other DLT implementations. You might be doing it for a client, you might be doing it for yourself, for the companies that you work in. If you want, please connect with us. We would want to enable you so that you could use it, and maybe the custom changes that you would want to do, you would want to contribute it back and be a collaborator with us on the Hyperledger Labs umbrella. So that would be great. What we have pasted here is our Rocket chat. So if you have any queries like the question and answers you had now, you can post them even going forward on our Rocket chat. We will be happy to answer them. So I'll just take a pause on that if there are any questions.
No. Yeah, I mean, given an example of a collaboration, I guess, from this details, there was a new feature request that has been put for using Spinnaker to do the automation, which has been put by one. I don't have the name now, but yeah, so similar, you can always put those feature requests, and it would be great to put them and maybe work on them as well. Thank you. That's all.
There was a question. Yes, BAF is being used by Accenture to run prod networks. Yeah, I can't name the clients, but we have already done it for 3 different use cases.
Yeah, and
3
just
different
on
clients.
a success story wise, one of those clients, they actually started with the POC, and they were so happy to just move it to production because it was so easy for them.
Yes, and we have also, got the input from the development and implementation teams that once they were enabled, they could actually save 80% of their network deployment time, specifically during the development phase where you have to bring up the network, bring down the network, do that multiple number of times. So
yeah, for example, your chain code didn't work and you want to clean the network. It's much easy to delete the whole thing. We have a reset, so you can delete the blockchain network without the risk of thinking that, oh, how will I create it ever again in like next hour.
yes. So if once this is up and running, I mean, if you have all the prerequisites done, then the best timing has been under an hour. So that is a very good achievement, I would say, where you don't have to worry about the complexities, and it is done automatically. Rachit, to your question, the CA for prod network, yes, in one of the implementations, they used their own certificate authority, while in on the other, even going against our suggestions, they used the Fabric CA. So yeah, different clients, different architecture teams, and different implementations. Sachin, to your question, how large is the network in prod? Number of orgs, number of nodes. I think the one, generally nobody goes big bang in blockchain. I hope all of us have realized that, right? So we have generally started with, MVP, which is minimum viable MVE ecosystem, 3 organizations, and then it is being scaled to larger network in prod. Okay, so I think we have answered most. Julian, we will hand it over to you for final words and closure.
Okay, well, thank you very, very much. I think that was an excellent overview, and actually very detailed view of BAF. And I think I'll just reiterate what you said at the end. I think it's important that people contribute. This is truly open source. So actually, maybe you should put, I saw the chat, which is our Rocket chat, which is available to everyone. Maybe you put that link in the chat so people know, in our chat, so they know how to contact you. But yeah, thank you, Priyanka, and for your overview today. Yeah, I think we'll wrap up there. And please, everyone, get involved. It's a great opportunity to get involved in this project. Thank you. Take care, everybody. And we will be sending this video out. It will be on YouTube, so you will be able to review this video again or share it with others. Okay, thank you.
Thank you.
Thank you.